And this week, China pulled it off. You're looking at a Long March 10B rocket that was launched from Hainan in southern China on early Friday. About 6 minutes after launch, the upper stage separated from the booster, and the first stage booster came down and landed on a drone ship in the ocean. But if you look closely, there's this cage that the rocket goes into and then hooks, and the landing net grabs onto it and softens the landing. But still, first successful reusable rocket landing done by China. The competition is starting to heat up.
全球可重复使用火箭的牌桌，过去几乎一直由 SpaceX 掌控，但这一次，中国火箭真的从天上落了回来，竞争格局开始变了。这位外国博主全程盯着画面，当一级火箭冲进海上捕获装置，被着陆网稳稳接住时，他直接承认，中国这次成功了。这不是普通的火箭降落。中国没有完全复制 SpaceX， 而是让火箭进入笼式结构，再用挂钩和捕获网缓冲着陆。真正让他警觉的是，中国已经从此前的海上软着陆测试推进到准备把这款可重复使用火箭正式投入运营。更有冲击力的是，长征10号 B 计划把约16吨载荷送入近地轨道。运力已经被他拿来与 SpaceX 猎鹰9号正面对比。当然，中国现在还远没有追上 SpaceX， 因为对方每年发射约150枚火箭，部分火箭甚至能够重复使用数十次。但最危险的反差也在这里。中国虽然仍在追赶，却已经跨过能不能成功的门槛。接下来比拼的是速度、频率和规模。火箭回收的震撼还没有结束，中国天问2号又逼近一颗只有约 27.4 米宽、形状近似三角形的近地小行星。它不仅要近距离观察，还准备采集样本并送回地球。完成任务后，还将继续转向一颗彗星，挑战并没有停止。接下来，让我们跟随外国博主的镜头，看看中国如何完成这次关键回收，又为何让全球航天竞争突然开始升温。
China's attempts at entering the reusable rocket space. There are a bunch of companies within China, as well as the government, attempting to build reusable rockets to kind of match what's happening with SpaceX and Blue Origin and Rocket Lab. And this week, China pulled it off. You're looking at a Long March 10B rocket that was launched from Hainan in southern China on early Friday. About 6 minutes after launch, the upper stage separated from the booster, and the first stage booster came down and landed on a drone ship in the ocean. This is a little bit different from what SpaceX does. They just have a floating platform in the ocean that the rockets land on, or they can land near the launch site on the ground. But if you look closely, there's this cage that the rocket goes into and then hooks, and the landing net grabs onto it and softens the landing. And this success follows from a test of a Long March 10A rocket that we saw back in February, where they landed in the ocean and were able to actually land softly on their landing platform. With this test out of the way, they're moving towards actually putting this rocket into operation. And the plan is that the Long March 10B will be capable of launching about 16 tons to low Earth orbit. And that puts it in the same class as the SpaceX Falcon 9. But, this is an important success, but keep in mind that the Falcon 9 has been doing this for years, that SpaceX is launching about 150 rockets per year, that many of the rockets can do dozens of reuses. So now there's a lot of catching up to do to actually get to that kind of launch cadence. But still, first successful reusable rocket landing done by China. The competition is starting to heat up. We've got two close-up asteroid encounters to report on this week, and I've been watching both of them quite excitedly because like every asteroid is special. And now we've got two more that we're seeing up close to put those photons into our eyeballs and start doing some chemical analysis of their surface. First up, the Japanese spacecraft Hayabusa 2 has given us some close-up images of the asteroid Torfune. Now, Hayabusa 2 was the mission that was sent to retrieve samples from the asteroid Ryugu and then bring those samples back to Earth. That work is done. Those samples are down here on Earth. But now Hayabusa 2 still has fuel, still has a lot of life left in it. And so the Japanese Space Agency is sending it on to several other asteroid targets. Its final destination is going to be this tiny asteroid called 1998 KY26. It's only 11 meters across, and we've never visited an asteroid that's that small. But on its way to KY26, the mission planners were able to give it a flyby of an asteroid called Torifune. And so last week, we got some incredible new pictures of this asteroid. This is an asteroid that is 450 meters across, and it's an S-type asteroid. So it's a stony type or silicataceous type. And these make up about 17% of the asteroids that are out there. And Hayabusa 2 came within 800 meters of the surface of the asteroid and took these pictures. And this shape, this peanut shape, has got to start feeling pretty familiar to you, that this is a contact binary. So originally, you had two asteroids that were orbiting around each other. They got closer and closer and eventually just merged into this sort of double-lobed blob. And it also looks very similar on its surface to the rubble pile asteroids that we saw with Ryugu and with Bennu from OSIRIS-REx. And so now we got this flyby of Torifune, and now Hayabusa 2 is continuing on, and next it's going to do a flyby of the Earth in 2027, and then another flyby in mid-2028, and then in 2031 it's going to reach its destination, which is asteroid 1998 KY26. And this is the tiny one, 11 meters across. Man, I love Hayabusa 2. I've got a story about this from Evan Goff. And then the second mission to reach an asteroid destination is the Chinese Space Agency's Tianwen-2. And this asteroid is designated 2016 HO3, but its casual name is Kamo'olawa, which is a Hawaiian name. And on July 2nd, the spacecraft came within just 20 kilometers of the surface of Kamo'olawa. And so now it's going to begin its observations of this very tiny rock. Its diameter is about 27.4 meters across, but it has a very strange, almost triangular shape. So we'll see what its sort of final size is after Tianwen has measured it. And it's going to collect a sample and send that sample back to Earth. And this is going to be the smallest object that we've ever received samples from. How do they differ from the samples that we got from Bennu and Ryugu? And this object is very interesting because it is a very rare type of orbit of near-Earth objects. They're known as Apollo asteroids, and they effectively share the same orbit as the Earth around the Sun. But they don't go into orbit around the Earth. They instead have this oscillation, this resonance that brings them to the Earth on a regular basis. And so in the case of Kamo'olawa, it comes by us every 45 years or so. And these objects are known as quasi-satellites. And there aren't very many of them, just a handful. But there are so many questions about this object. Is it a rubble pile? Is it monolithic? Is it one chunk of rock? Is there any water in it? Is there anything special about it? Well, Tianwen is going to give us answers and return samples to Earth. And then once Tianwen is done, it's going to move on to a comet. We're embedded in the disk of the Milky Way, and that makes it very tricky to actually measure the size and scale of the Milky Way. It's much easier for us to look out into space and see other spiral galaxies and measure their size. I always compare it to trying to figure out what your house looks like on the outside when you're on the inside. You know, maybe you see reflections off cars that are driving past to give you a sense of what your house looks like. But astronomers have come up with a really clever way to be able to figure out the size of the Milky Way's spiral arms. And this is using gamma ray bursts. They identified 3 gamma ray bursts that have happened in the past in the Milky Way. And gamma ray bursts are some of the most energetic explosions in the universe. A gamma ray burst can put out more energy than an entire star will give off in its entire lifetime, just in one fraction of a second. Gamma ray bursts can be caused by newly forming neutron stars, a collapsar. They can also be formed by merging neutron stars. And you get this powerful explosion and this blast radius that goes out into the intervening regions. And so astronomers were able to see the light echoes where the gamma ray burst blast is reflected off of dust clouds in the spiral arms of the Milky Way. And that allowed them to figure out where those spiral arms are. And they found out that they're about 10% farther away than we thought they were. So the Milky Way spiral arms are like a little bit bigger than we had thought. And we've got a story about this from Matt Williams. Scientists are continuously discovering the effect of spaceflight on the human body, and it's not good. Now, we know that long-duration spaceflight causes muscle loss, bone loss, causes fluid to redistribute in the body, causes problems with eyesight, but there are also longer-term effects on the human body, like right down to the genetic level. And so one of the big questions as we consider going out into space, trying to go to other worlds like Mars, what effect is that going to have on the human body for that long duration? So scientists have tried to mimic some of the conditions of deep space flight with animal models. And they have been able to mimic microgravity and radiation effect on animals. And they were able to show that the kinds of conditions that humans might experience in space will age us. They found the livers showed a wave of genetic changes that are very similar to the natural aging process. You get kinds of inflammation and fibrosis that can actually push these organs further towards failure. And just as a comparison, the scientists checked the research that had been done on Scott Kelly. So if you remember the astronauts Mark and Scott Kelly, they're identical twins, and both were NASA astronauts. And so this was the perfect example to test what happens to the human body when someone goes to space. Mark stayed on the ground, Scott went to space for a year, and then they were able to measure all of these genetic differences between them, all of the changes to Scott's body that didn't happen to Mark's body. And so the scientists, when they were looking at the increased aging rates on the various organs of the animals, were able to then double check the other kinds of indicators that they saw in Scott Kelly with his flight in space. And so that gave them a chance to just double check what they were seeing. And the reality is just that being in space for long periods of time is going to age various organs in your body. So there is one weird side benefit that you get from realizing that spaceflight makes aging go faster. And that is that if we want to study aging, then we have a natural lab that we can test this out. You can send animals or people to space, and then you can measure the effects of aging on the body in an accelerated rate. And so you don't have to wait a long time for your experiments to complete. And don't forget to like this video. It only takes a second and it means a lot to us. And so if you really want to go to space for a long period of time, if you want to go live on Mars, you can allow people to study your body and understand how you are aging more quickly than what you would if you just stay down on the surface of the Earth. We've got a story about this from Mark Thompson. I talk a lot about the dangers of radiation in space. You've got radiation coming from the sun in the form of the solar wind, as well as you can have coronal mass ejections and solar storms, lots of high energy particles moving through the body of the astronauts. And then you've also got the galactic cosmic radiation. These are high energy particles that are coming from everywhere in space. And both of these can contribute to long-term damage of the human body. You're essentially exposing yourself to high amounts of radiation, hundreds of times more radiation than what you would experience down on the surface of the Earth. Now, the Earth protects us with its global magnetosphere. There's a dynamo inside planet Earth that can then extend out and redirect these dangerous particles. And you match that with the atmosphere, and we are much safer from radiation because we are protected by our planet. But once you go to space, that protection goes away. And the idea forever has been, can we make an artificial magnetosphere? Can we use electricity to make magnets that will then redirect the flow of high energy particles? And when I look back in the literature, people have been thinking about this idea since the 1960s. And the challenge has always been that the amount of weight that's required to generate a magnetic field that would do the trick is just much heavier than just carrying mass that you would use as shielding. You just carry metal. And the metal is more protective than the weight of the magnets to try and protect you. But there was a new paper where some scientists were wondering, what if you use permanent magnets? They're made of metal and would provide shielding, but they also would be able to deflect particles that are making their way through it. And so they set up an array of 1,482 3x3 magnets. And then they simulated the effects of solar radiation coming through these magnets. And they found that they did deflect about 20% of the particles. The problem is that it's the lowest energy particles, the ones that cause the least damage. The ones that are higher energy are still making their way through this array of magnets. And then it doesn't do anything to stop the galactic cosmic radiation. And of course, permanent magnets can wear down over time, but they are made of metal. And so they do provide that protection for just their mass, and you get the additional benefit that they're going to be able to deflect some of the particles. So it's definitely an idea that's worth pursuing. Got a story about this from Andy Thomaswick. Every week, we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was that the Vera Rubin 10-year survey has begun. That was overwhelming. So thank you everybody who voted. Of course, we are going to put this week's vote into the post tab here on our YouTube channel. But if you want the best chance to see them, go into the post tab and then vote on a bunch of stuff. That will train the algorithm. And you should subscribe to the channel. You should click the notifications bell. You should like this video. You should make a comment for the algorithm. Do all the things. Back in May, Blue Origin's New Glenn rocket exploded on the launch pad, causing an enormous amount of damage to the launch complex Pad 36. And now we got a little bit of information from Blue Origin about what happened, what the damage was, and what their plans are going forward. So first up, they don't know the root cause. They're still trying to investigate and figure out why that rocket exploded. But they had enough cameras and sensors that they know that the explosion began in the aft section, sort of near the engine. So they're still working that part out. Now, what about the damage assessment? So according to Blue Origin, they lost the lightning tower, the transport erector, and the hydraulic cylinders. But the tank farm, the integration facility, the vehicle access tower, and the water tower are all still in good shape. And so this is changing their plans for how they want to move to the next phase of the New Glenn. There's a new version of the rocket that they're developing called the 9x4, and this is going to have more launch capacity. And so instead of just rebuilding the same transporter, they're building a new consolidated hybrid vertical horizontal launch platform. And so this will bring rockets out of their integration facility and then put it up in place for it to be able to launch. So no date on when they're going to be bringing the launch facility back online, but in the post, Blue Origin said by the end of the year. So that's not long. And so we'll see if they're able to meet that deadline and get back into launching from that complex. But they do have another launch complex that they'll be able to keep launching from. So we might not have to wait until the end of the year to see the next New Glenn rocket take off. The European Space Agency's Euclid mission is hard at work cataloging the cosmos. And in fact, there was a big science release that came out last week. I was looking through the journal and there must have been dozens of papers coming out from Euclid. So we're starting to get some really solid information from Euclid. One paper was talking about the quasars that Euclid has been discovering, especially the high redshift, the really distant quasars. Now, quasars are actively feeding supermassive black holes. They're some of the brightest objects in the universe, and so they can be seen billions of light years away. And Euclid turned up 31 never-before-seen quasars in a 3,000-degree part of the sky, which is a pretty big chunk of the sky. But what's really interesting is that it found the most distant quasar ever seen with a redshift of 7.7. And that corresponds to about 670 million years after the Big Bang. And this backs up some of the observations that we've been seeing from James Webb, that gigantic black holes were already present early on in the universe, actively feeding, blasting out radiation. It is still a puzzle. And so the most distant quasar. Got a story about this from Evan Goff. I don't want to make you feel old, but it is the 4th anniversary of James Webb. This incredible telescope has now been operating for 4 years, taking pictures of space and being about half of the things that I report on in Universe Today and here on Space Bites. And so to celebrate this anniversary, the folks behind James Webb released this incredible picture of the Centaurus A galaxy. It's also known as NGC 5128. It's located about 11 million light years from Earth. So it's one of the closest galaxies to us. It's only visible in the southern hemisphere. I've never seen it in my telescope, but it's very active and has a supermassive black hole at the heart that is feeding on surrounding material. And the galaxy has a very strange shape to it. It clearly went through some kind of gigantic collision within the last few billion years. It has this strange S shape at the center. and the black hole is sending out jets of material that are shaping the structure of the regions around it. All right, so happy 4th birthday, James Webb. Here's to many more. Got a story about this from Evan Goff. You're watching this episode on YouTube. You like your video. I get it. We put a lot of effort into making the really cool images and illustrations that go along with these stories. But many of you like to listen to podcasts. I sure do. And so I don't know if you know, but we make every single episode that we do available as a podcast. So all of the videos, we turn that audio into a podcast. And so if you want to catch up on the stories that we're covering or listen to the interviews where you kind of don't need to see a lot of the visuals, do a search on whatever podcatching app that you use to find the Universe Today podcast. And the podcast has all of the bonus material in it as well. So you can listen to the bonus story about a plan to build extending tunnels for a Mars base. I hope you're enjoying this week's episode of Space Bites. Of course, this is just a fraction of all of the news that we cover on Universe Today. We cover dozens and dozens of stories. We're very busy. And if you don't want to go and refresh the Universe Today homepage every few seconds, I understand. And so you should just wait and receive my weekly email newsletter where I write up a description of all of the stories that we cover this week. I write every word. It's completely free. There's no ads. Go to universetoday.com/newsletter to sign up. I'm going to give you some final thoughts about how space is really scary. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Caradon, Chuck Hawkins, Commander Baylock, Dark Finga, David Giltonen, David Matz, Enthralled Reading and Math for Toddlers, Evan.Pro, James Clark, Jeremy Madden, Jim Berg, Marcel Smith, Michael Purcell, NASA Ocean Guy, Nordspace, OneStepForAnimals.org. Please follow my nephew at VBrick6994, Brankaidu, Richard Williams, Sean Sargent, Stephen Filer Bunley, Team 49, Telescopes Canada, Vlad Chiplin, Wolfgang Klotz, Zelda, It Was Funnier in My Head, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. Oh, poor Zelda. So in the process of researching the story about how spaceflight is going to age the body, it just reminds me how much we have this sort of copium that goes on about our thinking about spaceflight, that our collective experience of being in space, traveling to other worlds, has been informed by science fiction. And it has not done a great job in preparing us for the reality. And so we have this cognitive dissonance. We have these lessons that we have learned from science fiction that we now have to unlearn as we face the true reality of how scary space really is. That you've got obviously the lack of oxygen, you've got the radiation, the effect that weightlessness has on the human body, you've got the dangers of micrometeorites, you've got the fact that you don't have all of the things that Earth is doing for us, is providing all of that oxygen, the gravity, the magnetic protection. You have to replicate every single part of the condition down here on Earth, but out there in space. You have to bring every part of Earth with you to try and be able to keep yourself alive. But it is not easy. And we're not ready for that time when we'll be able to send large numbers of people to other worlds, because that's where they're living now. It is going to be a very dangerous adventure for the people who are prepared for the consequences of what it's going to do to their bodies when they go to, say, Mars and back. And that when we finally see those people setting off to Mars, trying to build some habitation on Mars, a permanent colony, whatever, that we will start to see what that long-term damage is. And that then I think finally we will be able to change our just balance in our minds about what spaceflight is really like. And the more that I learn about it, the more that I just sort of find it scary. And you should feel fear and do things anyway. Just because we are, the fact that we are understanding how scary space is allowing us to move into space, knowing the risks, preparing for the consequences, and being able to take action in advance to try and minimize the downsides. But they never go away. And I think about the explorers who would set off on these tiny sailing ships and try to circumnavigate the world. They would head out to deep sea, and you see these videos of just waves that are tens of meters high that are crashing into boats, and just how scary that must be and how many people died making these journeys. And that when we first set out to other worlds, we want to try and avoid that. We have scientific understanding, we have skills, we have practice, but man, space is so scary. And I hope that we will have a much better understanding of how scary space is. And also we'll have the incredible accomplishment of dealing with all of those scary things and being able to have that be another mountain that we were able to climb. You know, it makes it worth it to overcome those challenges for us to set foot on another world and show that we are continuing outward from this cradle of planet Earth. I'm not saying we shouldn't go. I'm just saying, man, it's scary. And so we should be very careful.
看完今天的内容，真正让人震撼的绝不只是中国又发射了一枚火箭，而是中国终于跨过了可重复使用火箭最关键的一道门槛。过去只要提到火箭回收，外界首先想到的几乎都是 SpaceX。但这一次，中国1级火箭在升空约6分钟后完成分离，随后返回海面，进入特殊的笼式捕获装置，再由挂钩和着陆网减缓冲击。外国博主看完之后只能承认，中国这次真的成功了。更值得注意的是，中国并没有完全照搬 SpaceX 的海上平台降落方式，而是展示了另一套回收思路。从此前的海上软着陆测试，到如今成功完成回收，再到准备推动长征10号 B 投入运营，这说明中国的目标不是制造一次轰动，而是试图把技术验证转化为可以持续运行的航天能力。当然，我们也必须看到现实差距。SpaceX 已经在这一领域发展多年，每年发射大约150枚火箭，许多火箭可以重复使用数十次。中国刚刚完成重要突破，距离如此高的发射频率和成熟度仍有很长的路要走。但真正让竞争升温的，恰恰不是中国已经全面赶，而是中国已经证明这条路它走通了。接下来，问题不再是中国能不能回收，而是它多久能够把一次成功变成稳定、高频和规模化的能力。与此同时，天问2号又已经逼近一颗非常小、形状奇特的近地小行星，准备展开观测、采样，并将样本送回地球。完成后，还将继续飞向彗星。火箭回收与深空采样同时推进，中国航天正在面对的已经是更加复杂的下一阶段。那么，长征10号 B 正式投入运营之后，中国能否迅速缩小与 SpaceX 在发射频率上的差距？这套海上捕获方式能不能经受连续任务的考验？天问2号又会从这颗神秘小行星上带回什么答案？欢迎大家在评论区说出你的判断。认同本期分析的朋友，别忘了点赞、订阅频道并打开小铃铛，因为真正决定全球航天竞争走向的，可能不是这一次回收，而是下一次成功究竟会来得有多快。